So we're looking at binomial distribution today. Now, in terms of you doing this, you won't necessarily have to fully understand it for year 11, but you will need to know for year 12, which is why we're doing it now. So for binomial distribution, there's your formula. Now, I want to make one little note about this, which is this section here. That is actually NCX. Okay? Otherwise, you might notice that everything else is pretty much the same. I might change it to that one. So what we did yesterday was we were looking at combinations. This is actually just a combination part multiplied in the front, and then you have these other bits which I'll quickly explain. So P stands for probability of something happening, and then 1 minus P is for something not happening. Now that should give you a hint as to what this is for, which brings us to the next bit. What this is for is if you have two things where one can happen and one cannot happen. So you have a scenario where you have either things happening. Oh, I can't spell happening. So what that means is, for example, the example they have for P and X is going to be they're going to jail and not going to jail. You can only have one scenario or the other. You can't have half a scenario. You can't be halfway to jail, for example. You're either in or you're out. Or if you're looking at a coin flip, for example. A coin flip is pretty simple. You either have the heads or you have tails. So that's one or the other. Okay? But one only per scenario. That'll become clear in a moment if you're not entirely sure on what that means. Now, before we go on, I need to mention that on your CAS, you have two different functions, and you'll need to know this for each one. There's one for PDF and there's one for CDF. This one is used if you want a certain type of scenario happening. So what that means is you want, for example, out of 7 coin flips, you want 3. So that would be what you would use PDF for. It's an exact number. CDF is when you have X and you want it to be greater than something. Oops, not 1. So for example, if you have 7 coin flips and you want it to be 3 or more, or at least 3, that's what CDF is for. Now note that when you're using CDF, it's less than or equals to. It shouldn't be greater to, I think anyway. Alright, so let's just go through. Find the probability of finding exactly 3 heads when a fair coin is tossed 7 times, correct to 4 decimal places. Now, you will get to use the calculator for most of this, so don't stress. All it is plugging it into your calculator once. You have a probability that you need to figure out. You have the total number that you need to figure out, and then your desired outcome. So probability is what for a coin flip? A half? Good. So 0.5. Now note that I'm going to use decimals for this. You can use fractions, but generally it's recommended for you to use decimals if you're putting it in the calculator. You'll see exactly why in a moment. Alright, so N. N is your total. So the what's it called? Not the outcomes. Anyway, the total number. So how many coin tosses do you have in total? 7. And next is how many outcomes you want. So how many outcomes you want here? 3. Alright, so I'll just show you the formula one more time, if I'm allowed to. How do I go back? There's no going back. That's helpful. Okay. Can I do that? Ew, that's not going well. Okay, so the formula is nx p to the power of x, and then 1 minus p to the power of n minus x. Okay. If you're wondering how I remember it, I don't actually memorize it. I actually figure it out as I go. So the way you figure out how it goes is the first bit shows you the total over the number of times you need. So it'll be 7 and a 3. Remember that's 7C3, which you can work it out by hand if you need to, but put it in the calculator. Probability is P, so what's our probability? 0.5. Now, the 0.5 is what we want, which is why I put the x on top of it, because there how many times it pops up. So how many times do we need? 3. Alright, then the other one's 1 minus p. What's 1 minus a half? A half. So we still have 0.5. And then n minus x. N is 7 minus 3 gives you a 4. And then from here you just plug it into the calculator, which we will do now. If I can alt tab. Alright, from memory it's still, nope, it's not on the advanced. I'm presuming action somewhere. The catalog. There must be a quicker way of doing that. Anyway, it's quick enough. Alright, so you might notice both of them are there. So just as a reminder, we are looking at working out a certain number where it's equal. So this is, if I can write it, this is actually PR of x equals to x. So do I use CDF or PDF? PDF. So we need PDF, which is this one. Okay. Double tap it. And then when you put it in, you need n comma x. So that should be 7 comma 3. I think. Or not. I'm going to use my cheat sheet. Let's see. I'm missing the probability, I see. So 3 comma 7 comma. Let's just use interactive, it's a bit easier. What is it? Interactive, distribution, discrete. Wow, what a long list. That one, then there you go. Binomial and so our x is 3, the number of trials, which is a total, is 7, and then the probability is 0.5. There you go. Okay? Alright, let's keep going. So, if you now have the at least scenario, I'm going to write it out by hand once first, and then we'll go on to put it into the calculator. We're not going to slowly spend time doing it by hand because that'll take a very long time. So, this says at least 3, and the other thing is you also need to know the total number, which is 5. Alright, I'll just read it out once just in case anyone hasn't read it. The probability that a person currently in prison has ever been imprisoned before is 0.72. Find the probability that of 5 prisoners chosen at random, at least 3 have been imprisoned before, correct to 4 decimal places. So if we're writing this out, we want the probability where you have at least 3, which means what probabilities do we want? What do we want to start off with if we're starting from at least 3? Wait, how many? Sorry, I should say how many times do we? How many prisoners do we want going to prison first? Which is a bad way of saying it. 3 first, then next one. We want 5 up to 5 prisoners. So 3 and then 4 and then 5. Like I said, don't stress, your calculator will work this out for you. So if we painfully write all of this out, we want the total of 5, 3, our probability is 0.72 of them going back to prison. And then 1 minus 0.72 is 0.28. 5 minus 3 is 2. Plus, you can see this takes a while, which is why you don't normally do it by hand. 72 to the power 4, 0.28 to the power of 1, plus 5, 0.72 to the power of 5, 0.28 to the power of 0. Now, once you've done all that, obviously we don't want to put this, we don't want to work this out by hand because this will take a very, very long time. So let's go back to the calculator again. Alright, back to the calculator. Again, same thing, but this time around, we're going to use binomial CDF, not PDF. Now, you have lower and upper limits because you need to tell it where to stop. Where are we starting? What number? 3. What number are we ending on? 5. How many total trials can we have? 5, because there's 5 prisoners. And then probability of success is 0.72. And there's your answer. Okay? Alright, so last one. Probability of a netballer scoring a goal is 0.3. Now, you always need to know the final number, which is 6, and you want to score a goal 4 times. So, to score a goal 4 times, what would our... Just tell me what n is, according to this question. 6, good. Tell me what x is. 4, and the probability. So then you just simply put in 6, 4, 0.3 to the power 4, and 0.7. What power is that one? 2. Fairly straightforward, right? You guys get the idea? Just a note, you don't really need to put that in the calculator. Now, if you have a given probability, which is the only reason why I put this question in, if you have a given probability, what do we need to do if I'm writing this out? Yep, so we need a line in between. So let's write this out 4 times. So what would I write for this first part to show you that we want, we're going to have 4 goals? X equals to 4. And then on this given part, what would I write? It says given that she scores at least 1. So we want all the scenarios to be greater than 1. Okay? So obviously, work out x greater than or equal to 1. Then we need, in order for this to have an intersection, we would need the probability to be greater than 4, sorry, equal to 4, over the probability of you getting more than 1 goal, correct? Because this is just using the intersection notation of probability of x equals to 4, as well as it being greater than 1 goal. over x greater than or equal to 1 goal. Any questions? So the rest is really just a calculator thing, and I'll let you work it out.